Hello, welcome to CREATA classes. I am Gurmeet Singh. In this lecture, we will cover the questions on the surface area and volume of cylinder. Note that this lecture is part of complete series on volume and surface area of 3D solids. So let's begin the lecture. Our first question is, if the lateral surface of a cylinder is 94.2 centimeter square and its height is 5 centimeter, then find first the radius of its base, second its volume. We will go step by step. Our first step, we will observe and visualize this question. This question is talking about a cylinder whose lateral surface area is given as 94.2 centimeter square. What is lateral surface area? Lateral surface area is the surface of lateral wall, the same fundamental we have seen in the cuboid. Here for this cylinder, the lateral surface area will be equal to only the surface area of the curved surface. Here we have excluded the top face and the bottom face. Only the surface area of the curved surface will be considered. Okay? So only the lateral surface area of the cylinder is given as 94.2 centimeter square. And what is the surface area of the curved portion of the cylinder? It is equal to 2 pi RH. So here 2 pi RH is given as 94.2 centimeter square and height is given as 5 centimeter. And we have to calculate the radius and the volume of the cylinder. On putting the value and assuming pi as 3.14, we got the radius as 3 centimeter. Got the point? We have simply applied the formula of lateral surface area, that is the surface area of the curved portion of the cylinder. Okay? Further, we have got the radius, that is the first part of the question. In the next part, we have to calculate the volume. So what is the volume of the cylinder? Volume of the cylinder is pi r square h. So we know the radius as 3 centimeter and in the question the height is given as 5 centimeter. Let's solve it. We got the answer as 141.3 centimeter cube. Okay, that is the answer of the question. Let's move to next question. The question is, a hollow iron pipe is 21 centimeter long and its exterior diameter is 8 centimeter. If the thickness of the pipe is 1 centimeter and iron weighs 8 gram per centimeter cube, then the weight of the pipe is, 4 choices are given. Let's approach the question. This question is talking about a hollow iron pipe. This is an important concept. It involves a hollow cylinder. Hollow pipe, it is a hollow cylinder. So this question involves a new concept. Let's take a hollow pipe, that is a hollow cylinder. The length of this iron pipe is given as 21 centimeter. That is, the height of this cylinder is 21 centimeter. The exterior diameter is given as 8 centimeter. And the thickness of the pipe is given as 1 centimeter. Okay. Here the exterior diameter is 8 centimeter and thickness is 1 centimeter. So can we say the inner dia of this hollow pipe will be equal to 8 minus 1, that is 6 centimeter. What we have done? We have subtracted the thickness of the pipe from the outer diameter. We got the inner diameter as 6 centimeter. And in the question, we have to calculate the weight of this pipe. Basically, density of the iron is given, that is 8 gram per centimeter cube. Basically, the fundamental of the physics will be applied. That is, density is equal to mass over volume. Mass, that is the weight that we have to calculate, and density is given. So basically, we have to calculate the volume of this pipe to find the weight of this pipe. Getting the fundamental, one additional formula of the physics will be used, that is density is equal to mass over volume. So let's see how to calculate the volume of a hollow pipe. We have seen the volume of a cylinder is equal to pi r square h. That is the cylinder which is completely filled, that is a complete cylinder, but here it is a hollow cylinder. Means we have to calculate the volume of only the iron pipe, that is the metallic portion only. So how we can find the volume of this iron pipe only? We can do so if we find the volume of the complete cylinder and we subtract the volume of the inner cylinder, that is this cylinder, we will got the volume of the iron piece only. Got the point? So we can say volume of the iron pipe will be equal to the volume of the outer cylinder minus volume of the inner cylinder. Okay, let's assume R1 as the radius of the outer cylinder and R2 as the radius of the inner cylinder. Can we say the volume of the outer cylinder will be equal to pi R1 square h? Here R1 is the radius of the outer cylinder and h is the height of the cylinder. Further, the volume of the inner cylinder will be equal to pi R2 square h. Here height in both of the cylinder will be same and R2 is the radius of the inner cylinder. So let's take pi and h as common. We got pi h times R1 square minus R2 square. And here R1, that is the radius of the outer cylinder, will be equal to half of the diameter, that is 8 by 2, which is 4. And R2, that is the radius of the inner cylinder, will be equal to half of the diameter, that is 6 by 2, that is 3 centimeter. So we got R1, R2 and h is given in the question as 21 centimeter. Let's put the value. On solving, we got our final answer as 462 centimeter cube. That is the volume of this iron pipe. That is the hollow pipe. Got the point? By this fundamental, you can calculate the volume of any hollow cylinder. What we have done? We have calculated the volume of outer cylinder and we have subtracted the volume of inner cylinder from this outer cylinder. Okay? So this is one of the important fundamental. But in the question, we have to find the weight of this pipe. So let's use the formula, that is density is equal to mass over volume. So let's put the volume and density is given as 8. So we got the final weight of this pipe as 3696 gram. Okay, we got the weight of this pipe as 3696 gram. But all the 4 choices are given in the kg. So let's convert the gram to kg. Let's divide this term by 1000. We got our final answer as 3.696 kg. That is the answer of this question. Got it? Let's move further to our next question. The question is, the curved surface area of a cylindrical pillar is 264 meter square and its volume is 924 meter cube. Find the ratio of its diameter to its height. 4 choices are given. Let's proceed with the question. The question is talking about a cylindrical pillar. Means our 3D shape is a cylinder. The curved surface area of the cylindrical pillar is given as 264 meter square. Point to be noted here is that the surface area given is the curved surface area. Means top portion and bottom portion are excluded from the surface area. Means only the lateral surface area is given in the question. We know what is the lateral surface area. That is 2 pi RH. Okay. Means 2 pi RH is given as 264 meter square. Further, in the question, the volume is also given as 924 meter cube. And we know what is the volume of a cylinder. It is pi square h. So, pi square h is given as 924. And in the question, we have to calculate the ratio of diameter to its height. So, basically, we have to find the diameter, that is the radius of the cylinder, and we have to find the height of the cylinder. Let's approach the question. Let's divide both of this equation. On solving, we got the value of r, that is the radius of the cylinder, as 7 meter. We got the radius of the cylinder, so we can find the diameter, which is twice the radius, that is 7 into 2, that is 14 meter. Okay, we got the radius and the diameter. Let's find the height of the cylinder. Let's use this equation and we know r as 7 meter. Let's put the value. We got height of the cylinder as 6 meter. So we got diameter and height. Let's calculate the ratio. On putting the value, we got the final ratio as 7:3. That is the answer of this question. Got it? Okay students, we have done with the right circular cylinder. In the next lecture, we will cover the right circular cone. So that's for this video. Thank you very much and best of luck for the exam you are preparing for. Note that this is the series on volume and surface area of various 3D solid. So best of luck and have a great day. Bye for now.